Alright guys, how are you all doing? Okay, today we shall be looking at parabola, one of the aspects of conic section. In the previous class, we were able to classify conics into four. Now the first is called the circle. Second, we have the parabola, we have the ellipsis, and we have what we call the hyperbola. Then in our previous class, we discussed extensively on circle, where we looked at circle of different form. We look at the standard form of a circle, and also we look at the general form of a circle. And we define circle as the set of all points, or the locus of a point rather, that are in equidistance from a fixed point called the center. And the center of the circle we represent as h, k, right? So today, we're looking at another aspect of conic section, which is called the parabola. But don't forget that in a circle, we have what we call the locus of a circle. In a circle, this is a circle, and we have the center, which is h, what? K. So every point from this center to the locus are in equal distance from each other. So if I have here to the center, and yes, the locus P, S, Y, that simply means that from this locus here, we call it R. That means that what defines a circle is actually CP equals to what R. Meaning from the center to the locus point equals to the radius. So if we have here to be locus 1, and yes, locus 2, yes, what locus 3, yes, locus 4, yes, locus 5. That implies that every distance from the center to each locus is equal to what? R, right? Okay, because this is what defines a circle. So from the center to the locus are what in equidistance. So that simply means we can have this to be CP1 equals to R, or CP2 equals to R, or CP3 equals to what? R. Even CP4 equals to what? R. So from the center to each of these locus are in equal distance, which is what? Our radius, right? Okay. Now, parabola. Look at the parabola. When you hear the word parabola, what comes to your mind is quadratic equation or quadratic graph. Every quadratic graph, they are parabolic graph in nature. Every quadratic graph are what? Parabolic what? Graph. Okay? So every quadratic graph or equations can also be regarded as what? A parabolic what? Equation. So when you hear the word parabola, just have it in mind that we are regarding or we are referring to parabola, all right? Or when you hear the word parabola, just know that we are referring to what? Quadratic, okay? And you know, one of the nature of a quadratic equation is that the highest power of one of the unknown is always what? 2, okay? For example, if we have this s squared plus 6s plus what? Plus 5. This is the quadratic graph. Sorry, equation rather. This is a quadratic equation. This can also be referred to as a parabolic equation. But let's define a parabola. What is a parabola? Now that we know that the nature of a parabola is simply quadratic, right? If we have a curve like this, then when you plot a graph, a quadratic graph, when you plot a quadratic graph, you will have a graph of this form. Either the graph will move this way, we go upward, we open upward, or the graph will come this way, right? Or the graph can sometimes be this way, or can also be sometimes in this way. Any of these describe the nature of a parabola. Okay, it describes the nature of a quadratic graph. Now, we are already saying on having a clue on what parabola looks like. Now let's see. Let's define the parabola. A parabola, in real sense, is defined as the set of all points on the plane that are in equidistance from a fixed point called the focus and a fixed line called the directrix. Now let me explain. There are certain things you have to take note in the parabola. One of such is actually what we call focus. The focus is always the center of the curve. It's more like the center of the curve where light rays either emerge, right, or diverge. When we talk about light and light in optics and all that. Okay, the focus is like the center of the curve, is the point rather where light rays either emerge or diverge from. Is it not so? So yeah, if we have a parabolic curve, this parabolic curve, if you look at the quadratic, if you look at the Cartesian diagram, we have the y, the x-axis. This curve is actually enclosing what? the negative x-axis, because this is negative x, this is positive x, right? This is positive y, this is negative what, y. Okay, now, let me define parabola. Parabola, I said, is a set of odd points on the plane that are in equidistant from a point called what? The focus. And a fixed line called what? The directrix. Meaning that from the focus to this plane equals from this plane to a line called the word directrix. So if from the focus to this plane, let's call this plane P, which is x comma what, y. If from here to here is actually 2 units away, that implies that from this point on the plane to this line called the word directrix is also what, 2 what, units away. Are you there? Okay, guys. Now let's define other points in this parabola. From here, from this focus to this point equals from this point to this line called the directrix. From the focus again to this point equals from here to here. From the focus to this point equals from here to here. Then also we have a straight line which passes through the focus, that passes through the focus. And from this point here down to this point is called 2p. While from here is also called what? 2p. So that means from the edge here, let's say if here is A and here is B, from point A to point B will be 4p, because 2p plus 2p is what? Is 4p. That means our latus rectum, which is a straight line, or focus, is equal to what? 4p. Now please be taking note of these terms we are talking about. Now there's another term called the vertex. The vertex is just like, is a point in a parabola, okay, where the turning effect of that curve takes place. Or I can say that the vertex is a turning point of the parabola. Is a turning point of the parabola. So the vertex is simply this edge here. This is the turning point. So if we have a curve like this, if you have a curve like this edge here is called what? The vertex. If we have a curve of this form, this edge here is called what? The vertex. If we have a curve of this form, this edge is called the vertex. It's called a turning point in the parabola. The turning point in the parabola. Okay, guys. So now, let's look at the nature of a parabola. Like we described in a circle, that a circle can either be at the origin or away from the origin. So I'll be looking at the equation of a parabola. We have some case I'll be mentioning. Let's look at case 1. Under case 1, I'll be talking about when the parabola is placed at the origin. So if I have a Cartesian diagram and the parabola, the vertex is actually at the origin. The vertex is at the origin. Origin simply means that the value of x and y is equal to 0, right? Good. So when the parabola is at the origin and the parabola seems to enclose the positive x-axis, it simply means that the value of y will be squared. So the equation of this parabola becomes y squared equals to 4px. Why do we have y squared equals 4ps? If you notice in this equation, we are squaring y. The reason because the parabola is enclosing the positive what? S-axis or the S-axis. If the parabola is enclosing the negative S-axis, the equation, that means we are assuming that this other curve does not what? Exist. If it does not exist, it simply means that the equation becomes y squared equals minus 4ps. Why is it minus 4ps? Because the parabola is enclosing the negative what? S-axis. Don't forget that at every parabola we have what called the focus, right? And please take note that from the focus to the vertex is always p units away. So for this kind of graph, our p is negative because the parabola is enclosing the negative what? Axis. Now also, if you look at this equation, let's say we have this graph. This graph is enclosing this region. Our P will be from the focus to the vertex, right? In this case here, our P is what? Positive. But for this kind of graph, our P is what? Negative. So the formula for this is y squared equals minus 4ps. Why the formula for this is y squared equals what? 4px. Why is it 4ps? Because the parabola is enclosing the positive what? S-axis. But don't forget that we said our latus rectum is described as what? 4p. That simply means the value of this 4p represents the latus what? Rectum. So latus rectum is given as what? 4p. Absolute value of what? Of 4p. Absolute value. Meaning, if at the end of the day we have latus rectum to be equal to minus 8, the answer becomes what? Plus 8. Which is absolute value of what? Minus 8 will give us what? Will give us 8. Are you following? Okay. Now we have seen a parabola at the origin. Let's consider when the parabola is not at the origin. When it's not at the origin, that means the parabola has its vertex away from the origin. You know, when the parabola is at the origin, that means the vertex is simply 0, 0. Please take note that for a circle, the center is h, k. But for a parabola, there is nothing like center in a parabola. We only have what? Vertex. And the vertex of all parabola is also same as what? H, what? K. The vertex of a parabola is same as what? H, what? K. This class is just to give you a fundamental knowledge in parabola, because in the next class I will now be solving some calculations and all that. Now just understand that these two forms of parabola are parabola when the vertex lies at the origin and the parabola is enclosing the x-axis. For this other side here, the parabola is enclosing the positive x-axis, then we have y squared equals 4ps. And why are we squaring y? It's simply because the parabola encloses what? The x-axis. So if the parabola is enclosing the y-axis, it simply means we're going to square what? X. Now let's see such kind of equation, or graph rather, still at the origin. Still at the origin, if we have this kind of graph at the origin, okay, let's call this first one, this first case, horizontal, right? Horizontal. This is horizontal. Okay. Don't forget that our vertex still remains what? H, k. But for this kind of parabola here, our vertex is what? 0, what? 0. Because why? The parabola is at the origin. Now, let's look at vertical. Vertical parabola. At the origin. At the origin. So if I have a case like this, please pay rapt attention. A case like this, okay, and have another case like this. What do you notice? The parabola has its vertex at the origin. From this vertex to this point is our focus. And this focus is actually what? P unit what? Away. So our P in this parabola is actually positive. Okay. Don't forget that the vertex is h, what? K. But in this case, it is what? 0, what? 0. Now for this, the vertex is here. The vertex, the parabola rather, is enclosing what? The negative what? X as y axis rather. So from the focus to this vertex is what? Minus P. Okay. Then it simply means that our P value here is what? Is negative. Let's define our directrix. From the focus to the vertex, okay, is equal from the vertex to what? A line called what? The directrix. The directrix is always outside the curve of the parabola. So it simply means that the vertex is actually halfway between the focus and what? The directrix. So for this, our directrix will be somewhere away from this curve. But this kind of curve, the p value is what? Is negative. Now let's describe the equation of this parabola. The equation. What do you notice here? You notice that we squared, the parabola actually encloses the y-axis. The parabola encloses what? The y-axis. Not just the y-axis, but positive y-axis. That means that we are going to square the x. So this becomes our x squared equals what? 4p y. Now you are seeing the whole thing now. For this, it encloses what? The x-axis. So we have to square what? Y. But for this, because it encloses the y-axis, we are going to square what? S. But the value of your lattice rectum here depends on where the parabola is what? Enclosing. So for this, the parabola actually encloses what? The positive what? Y. So we have plus 4py. Now, pause the video a little and tell me what will be the equation of this parabola. Now, what do you notice here? The equation will be what? S squared equals minus 4py. S squared equals what? Minus 4py. Alright. Now, we have seen generally parabola at the origin. When the parabola is enclosing the x-axis and also the y-axis. Let's define the value of our focus on this parabola. The value of this focus, if you notice, this parabola is actually along the x-axis. The value of this focus will be minus p, comma what? 0. The value of this focus will be, from this focus to here is what? P. And p is what? A positive. So that means our focus becomes what? P, comma what? 0. So for this, the value of our focus would be, if you notice, the P is along the y-axis, where S is 0. So here becomes 0, comma what? P. So here will be, focus will be what here? 0, comma minus P. Please take note of this because we shall be using this to solve some problems. Okay, let me define something again. Knowing that the vertex of this parabola is 0, 0, which is h, k. That means my h is 0, k is what? 0. There's something else I want to describe. I want to describe and show you how we can actually find the equation of the directrix. Okay, let's pay attention. Now look at this now. Don't forget that the directrix is always outside the curve. For horizontal parabola, you notice that the directrix actually cuts the y-axis at a certain point. So the equation of the parabola is always given as, for horizontal, is s equals to minus p. Whether the parabola is enclosing the negative x-axis or the positive x-axis. So that means that directrix for this other graph is still x equals what? Minus p. Now for this, what you notice here, the directrix is cutting the parabola on the y-axis. The equation of the directrix becomes y equals to minus p. So likewise this also, the equation becomes what? Y equals what? Minus p. Alright. Okay guys, let's look at when a parabola is not at the origin. When a parabola is not at the origin. Like I said, my major assignment today is to give you a fundamental knowledge in parabola, so you can be able to understand what a parabola is and how a parabola looks, and how can you actually determine the equation of a parabola. Okay, before you solve any equation in parabola, the first thing you have to do first is to look at the equation given to you to determine if the parabola is actually enclosing what? X axis or what? The y axis. And I'll be showing us in previous videos to come how we can actually solve problems in parabola. So make sure you subscribe to this video. Make sure you click on the bell. Okay? Make sure you click on the notification bell to get more videos that will be uploaded in this YouTube page. And make sure you like and comment. Alright? Okay guys. So let's see. Case 2. When a parabola is not at the origin, it's not at. It's not at the origin. It's not at the origin. How would this look like? Let's still look at horizontal. Let me show you something. For horizontal parabola, for example, if I have a parabola of this curve, and the parabola seems to look like this. If you notice, this parabola is away from the origin. The parabola is actually enclosing the negative x-axis. Inside the parabola is a point called what? The focus. The focus is always p units away. In this case, we have minus p units away. From this vertex, from this focus to the vertex, equals from vertex to what? A line called the directrix. Possibly it might even be on this line, or away from this line, or away from this line, depending on the value of what p. If p is 2, that means from here I have to measure out 2. If p is 5, if from your vertex to your focus is 5 units, that means from the vertex to the directrix is also what? 5 per unit. So sometimes it can be at this time, at this spot, or even along this line, or sometimes away from the line. All right? Okay. So let's assume that the directrix is actually somewhere here. Okay? All right. Now pay attention. The parabola here is enclosing what? The x-axis. Don't forget that when the parabola is enclosing the x-axis, we are going to square what? Y. And in the first case I gave us, when it's enclosing the x-axis, negative x-axis, we are squaring what? Y, right? And that gave us y squared equals what? Minus 4p what? X. This is for the origin. But when the parabola is away, I'm talking about not at the origin, away from the origin, here becomes y minus k all squared equals to minus 4p x minus what? H. Meaning there will be a deviation in y and what? And x. That deviation in y is minus k. Ys is what? Minus h. Don't forget that every parabola has a vertex. The vertex is h comma what? K. So when the vertex of the parabola is at the origin, we say h and k become 0 comma 0. But for this parabola away from the origin, the vertex remains h comma k, not 0 comma 0. That means that the parabola is actually formed on the Cartesian diagram at a certain point. Is it clear? So for this, we are going to maintain 2h comma k. This h can be 2, k can be 1. But for the origin means that the vertex is at 0 comma 0. So when it's away, that means at some point away from the origin, we can generate a vertex that has a value. Okay. So for this, I've defined the equation of the parabola, which is y minus k equals minus 4p s minus h. Why are we squaring here? Because the parabola encloses what? The x-axis. Not just x, but negative what? X-axis. But, okay, let's define the equation of the directrix. Of the directrix. Of the directrix. How would that be? This equation of directrix is going to be, at the origin, we are saying that the formula is s equals minus p, right? Minus p, is it not so? So for this, at the origin, here will be x equals minus p, the value we have at the origin, plus, since the parabola is along the x-axis, it simply means I'm going to add what to it? H. So here becomes x equals to what? H minus what? P. Don't forget that at the origin means x equals what? Minus p. Because the parabola is at the x-axis and x represents what? H. And away from the origin, it simply means I will add what to it? I will add h. So that means h minus p. Okay? Alright, this is the equation of what? The directrix. Then, the equation of the directrix still remains what? The same. Still remains the same. Because even if the parabola is this way or this way, at the origin, don't forget that we agree that it is still what? S equals minus p. But when it's now away from the origin, we're going to add what to it? H. So this formula here you are seeing here is horizontal parabola when it's either enclosing what? The positive x-axis or the negative x-axis. I mean this formula for directrix. Okay? This can go for negative s and also go for positive what? X. Now, let's look at vertical. Now I've defined a lot of things here. For vertical parabola, For instance, if we have parabola not at the origin, not at origin, not at origin. This is a very simple case. We can use this concept here. I've used to explain parabola, to also explain this. If we have this, the parabola is of this kind, let's say of this kind, then another parabola may possibly of this kind. This curve can either be here or here. You see the same p-value. This curve can either be here or here, the same p-value. For this curve, our p is what? Is negative. Because why? It is enclosing the negative what? Y-axis. For this, our p is what? Positive. Your directrix is along this line. From here we have our focus. This focus to the vertex is what? P units what away. We have our p here. Are you following somebody? Now for this, our focus is here. Here we have our p, but the p is what? Minus, because why? It's enclosing the negative y-axis. So from somewhere here, we can have what? Our directrix. Don't forget that our vertex is always h comma what? K. Vertex is what? H comma what? K. Now, what do you think will be the equation of this parabola? The parabola is enclosing the y-axis. It means I'm going to square what? The x. Don't forget that at the origin, when we square the x, we're going to have x squared equals what? 4p what? Y, right? When we square the x, it will be 4p y. If it's enclosing the y-axis, we square the x, right? In this case here, it's at the origin, right? But for this kind of graph, what will it be like? It's going to be, okay, it's going to be s minus h all squared equals 4p y minus what? K. So for this is going to be x minus h all squared equals minus 4p y minus what? K. Now let me ask this question. What do you think will be the equation of the directrix? Equation of directrix. Equation of directrix for this parabola is going to be the directrix is cutting the y-axis, is it not? It's going to be y equals minus p. Don't forget, this is just for, if I'm to stop here, this is for what? Origin, right? But because I'm dealing with not at the origin, and the parabola is enclosing what? The y-axis. The y-axis talks about the k value, right? So that means I'm going to add what here? Plus what? Plus k. Likewise, this, the same thing, equation of directrix is y equals minus p plus k. So this is same as y equals k minus p. This is also same as y equals k minus 1 p. Alright guys, now we have seen parabola. This is an overview of a parabola. This is an overview of a parabola. Overview. Now let me summarize all I've said so far. Now let's look at this. The summary of everything I've said so far. The summary of everything we have discussed so far in a parabola is simply this. If we are dealing with horizontal, sorry. If you are dealing with horizontal parabola at the origin, for origin, meaning that the parabola is enclosing what? The x-axis. So we have this, y squared equals plus or minus 4px. Plus simply means positive x. Minus means what? Negative what? X-axis. Is it not so? Our directrix, this is the equation, right? Okay. This is the equation of this parabola. Our directrix is simply going to be y. The parabola is enclosing what? The x-axis. okay, it's going to be x rather, equals to minus p. But when it's away from the origin, we're going to have what? Y minus k all squared equals plus or minus 4p s minus h. Then the directrix will become x equals minus p plus what? H, which is same as x equals h minus p. For this, our focus, we define focus as, when the parabola is in this way, our focus has a value on the x-axis, right? That means p, comma, 0. Or minus p, comma what? Comma 0. Now let's define the focus for this. The focus for this parabola away from the origin will be gotten from here. The focus, don't forget that our vertex is always h, comma 1, k. And since the parabola is at the x-axis, horizontal parabola, our focus will be, here we have h, right? Okay? H plus or minus p, comma what? K. Don't forget. H plus or minus p, comma what? K. Because the parabola is at the horizontal. So I will consider horizontal part. It means that I will maintain my k for the vertex. Then h, I will add or subtract p. Right? Now what do you think will be for that of vertical? Let's see vertical. I think there's something I didn't define yet in vertical, which is my focus. But let me do that now. Let's look at vertical. Everything you achieve in the horizontal will also be done, okay, in the vertical. But just that it will be like opposite direction. Now, for example, for origin, vertical parabola, yeah, we're going to have s squared equals plus or minus 4py. The directrix will now be y equals to minus p. Our focus will be, because the parabola is along the y-axis, right? So that means that the focus will have a value on the y component. So that means our x is 0, then the focus becomes what? Plus or minus what? P, right? Okay. This is also focus is plus or minus p, comma what? 0. You know, this is also same as 0, comma what? P, or focus, or 0, comma what? Minus what? P. Okay, let's look at away from the origin. The same thing we achieve here will be achieved, but just in opposite direction. This is at the origin. Then for that of away from the origin, we're going to have here becomes, let's go, when the parabola is at the vertical, okay, let's look at this again. Okay, for vertical parabola, all right, we say that we're going to be squaring what? Squaring x, right? So here becomes what? Our x minus what? Minus h, all squared equals plus or minus 4p y minus k, is it not? Okay, I think it's the reverse of this. Then our directrix, now who can tell me the directrix? You can pause the video to tell me what the directrix will look like. The directrix will be, because it's on the y-axis, becomes y equals minus p plus what? K. Or y equals k minus what? P. Okay. Then our focus is going to be on the y-axis. So that means that if our vertex is h, comma what? K, and the focus is on the y-axis, it means I will maintain h, then add what? Plus or minus p to the y-axis. So that means that k plus or minus what? P will be added to what? The y-axis. Alright? Okay. I hope we are aware that we can also expand this to be in this form. The focus is h, comma, k plus p, or h, comma, k minus p. Likewise, this as well, I can also expand this to be focus as h plus p, comma k, or h minus p, comma what, k. Alright guys, now this is a summary of everything you need to understand to know about a parabola. So in the next class, I'll be taking us extensively on different parabola equations, which I'm looking at how to find the focus of the parabola, how to find vertex, how to transform an equation, how to graph a parabola, and how to find the equation of a parabola. Also how to find the focus of a parabola and the directrix of a parabola. Sometimes you might be asked to find the domain of a parabola and the range of a parabola. All of this shall be discussed in my next video. So please ensure you subscribe to this YouTube channel. Ensure you click on the bell for you to be able to get more of our videos. Alright guys, thank you so much. I love you guys.